Now, let us proceed to lesson number 2, Measures of Central Tendency. At the end of the lesson, the students are expected to define what a measure of central tendency is, enumerate and define the three measures of central tendency, and solve for the mean, weighted mean, median, and mode of a given set of data. By definition, a measure of central tendency, MCT, is popularly known as an average. This may be referred as a single number, which will be used in some definite ways to indicate the central value of an entire group or observations. We have here two functions of measure of central tendency. First, it gives a concise description of the performance of the group as a whole. And second, it enables one to compare two or more groups in terms of typical performance. First in our list is the mean. The mean is the most common measurement of average. It is also called the arithmetic mean or the computed average, or average in general. The population mean is denoted by the Greek letter mu, whereas the sample mean is represented by bar x or x bar. Moreover, mean can be used when the data are interval or ratio. We have 7 properties of the mean. The first, it is the most reliable measure of central tendency since it takes into account every item in the set of data. Second, it can be calculated in any set of numerical data, so it always exists. Third, a set of numerical data has only one mean. Fourth, it is greatly affected by extreme values. Fifth, the sum of the deviations of all measurements in a set from the mean is 0. Sixth, it lends itself to a higher statistical treatment. 7. It is used only if the data are interval or ratio and when normally distributed. For the computation of the mean, we will start with the ungrouped data. When we say ungrouped data, the scores are not grouped or the scores are individually listed. To determine the ungrouped mean, the formula is bar x is equal to sigma x over n, where sigma x, known as the summation of x, can be obtained by adding all the scores or the given values divided by n, where n is the number of cases. For example, find the mean of the scores 12, 9, 15, 10, and 14. The procedures for us to follow to solve for this is the first one, get the sum of the scores or given measures and count the number of cases. That is 12 plus 9 plus 15 plus 10 plus 14 we will obtain a sum of 60. The second procedure here is to divide the sum by the number of cases. For this scenario, for us to get the number of cases, we will just count the number of cases or the number of scores. we have 1, 2, 3, 4, and 5. So the value of n for us to substitute here is 5. Hence, we will obtain the value 60 divided by 5 equals 12. Therefore, the mean of the scores is 12. Example number 2. The following are Zeus scores in his statistics quizzes during the first quarter: 87, 85, 89, 88, 86, 84, and 83. Compute for the mean or the average of the scores. Here, we are tasked to compute for the mean or average. Again, the procedures are: for the first one, we have to get the sum of the scores or given measures and count the number of cases. That is, 87 plus 85 plus 89 plus 88 plus 86 plus 84 plus 83, and we will obtain 602. The next step, or the last step, is to divide the sum of the number of cases, where n is equal to 7. And we will obtain 602 divided by 7 equals 86. Therefore, the mean or average of the scores of Zeus is 86. Example number 2. There are 1,000 notebooks sold at 10 pesos each, 500 notebooks at 20 pesos each, 500 notebooks at 25 pesos each, and 100 notebooks at 30 pesos each. Compute for the weighted mean. For us to solve for this, first we have to create a table for the scores, for the frequency, and the product of the score and the frequency. For X, we have 10, 20, 25, 30. And for the frequency, 1,000, 500, 500. And 100. Fx means we are going to multiply the frequency and x together. That is 10 times 1,000, 20 times 500, 25 times 500, and 30 times 100. And we will obtain 10,000, 10,000, 25 times 500 is 12,500, and 3,000. Now, get the summation of f times x, and we will get 10,000 plus 10,000 plus 12,500 plus 30,000 is 35,000. Next is to divide the summation of f of x to the given number of cases. For us to obtain this, we will just add 10. For us to obtain this, we will just add 1,000 plus 500 plus 500 and 100, and we'll get n equals 2,100. And now we are ready to compute for the mean. 35,000 divided by 2,100, and we will get 16.90. Therefore, the weighted mean is 16.9 or 16.90.